I run 4Berri Consulting, where I've got 20 years experience plus in large projects. We cover a multitude of industries, construction, defence, covering projects around the globe. And we specialise in schedule assessments and QSRA. That's really our bread and butter. And our aim is just to provide more realism within schedules for clients. And we've covered various clients, including EDF, BP, which this presentation is about, and others. So before I start, I'll just show a video of Shah Deniz. Okay, so I'll just run to the presentation. Hopefully that gives you an idea on the size and complexity of this project. It covers multiple countries. So if I go through a brief overview. It's located in the Caspian Sea, 90 k's from Baku, and the field was discovered over 20 years ago now. There was 33 trillion cubic feet of gas in a gas field that's 20 kilometers by 77 kilometers wide. So in size comparison terms, that's equivalent of Manhattan. It's a multinational project and supply chain runs throughout the globe. So in terms of the field itself, the water depth of the Caspian runs from 75 to 550 meters deep. And you've got very challenging topography, mud volcanoes, cliffs, so very difficult to drill down there. The floor is very wet, muddy, and it's very hard to get the drilling rigs through the floor. It became operational in 2006 for phase one. So phase two includes upgrading terminals, extensions to existing pipelines crossing Georgia, Turkey through to the Greek coast. So that's a brief overview of the actual footprint of the project. So you've got the Caspian Sea where the drilling rigs are. The pipeline for SCPX goes through to Georgia, through to a compressor station. And then Turnup and TAP, the two other pipelines, run through Turkey and Greece. So here you can see a focus in on the actual platforms located in the Caspian, where the pipelines start from the Sangashal terminal. This view is a view of the actual field itself, trying to orientate it north to south. So you can see by the close contour lines how steep the gas field is. With the red marks are actually mud volcanoes and steam vents. So drilling through the seabed floor is extremely challenging to make sure it's done in a safe manner. This again gives you a cross-sectional view of the field. So this brown section here is the actual gas field. You've got these steam vents coming up. These vertical lines are the actual drilling lines going through into the field. So in terms of the offshore scope, you've got 2 bridge-linked platforms for living quarters and also production. You've got a section of isolation valves, flow line termination assemblies, and 26 subsea wells. So effectively, that's where the drilling rigs drill through. The production hydrocarbon, in this case gas, flows through the wells and into the production trees and manifolds. We have manifolds on the seabed here. Because of the challenging nature of the seabed floor, it helps stabilize and also control the flow of gas. So a few graphics here on the complexity of the project. Hopefully the video gave you an idea on the size. So we've got some topside units here where the workers would stay. It's 13,000 tons in weight. Then you've got a secondary topsides platform where the production risers come through from the seabed, and this is at 16,500 tons. So these are fabricated onshore and then lifted onto a barge via a hydraulic system. These are one of the jackets that sit on the seabed, and you have some suction piles where these feet feed into, and eventually the topsides will sit on top of these jackets. In terms of the SCPX pipeline, so it's delivering gas to the Georgia-Turkey border. It's a 48-inch pipeline in parallel with the existing SCP pipeline. Runs almost 500 kilometers, and there's 2 intermediate compressor stations to be constructed. At the time now, those have now been fully constructed and gas is flowing. So it's really important to know that there's a safety zone around the pipeline that is handed over once the land has been acquired from the landowners. So you can't build any 3-story buildings or schools in the vicinity just for safety reasons. This gives you a view of the pipeline. So running from Sangashal terminal near Baku, across Azerbaijan, through to Georgia, and there's got the SCPX connection with Turnup on the west side of Georgia. So TAP and Turnup. So TAP stands for the Trans-Adriatic Pipeline, and Turnup is the Trans-Anatolian Gas Pipeline. They're classified as OBO, which means they're operated by other clients. So BP isn't the majority shareholder there. So here you can see Turnup. So it runs from the west side of Georgia through all the way to Turkey to the Greek border, and there's an offshoot to Bulgaria. And this pipeline runs almost 2,000 kilometers in length. And similarly with Turnup, takes the end of TAP and runs through Greece, through Albania, where it has landfall on the Italian coast near Lecce in Puglia. So many challenges on this project. As you might have noticed, Caspian Sea is landlocked. So we've got many issues with logistics. You get frozen canals to transport material down from the north of Russia down into the Caspian and through Azerbaijan. You've got multiple suppliers and countries, so pipe from Japan, wellheads from Houston, controls from Norway. We also mentioned about the geotechnical challenges on the seabed for the Caspian Sea. We've got multiple stakeholders, lengthy decision processes, and complex and aggressive schedules, which we'll go into a bit more detail. So here just gives an idea of the various canals that run through Europe. And the Volga-Don Canal was a primary tributary used to deliver items through to the Caspian. And you can see running down here to the Caspian, you've got these very elegant gate systems that run through the canals. These were seen as more important than the deliveries themselves. If a barge was to hit one of these, the fines will be astronomical. So you've got about 0.5 meters clearance either side of each vessel that going down the canal. So it's extremely important to keep these gates intact. The cross-section view on the bottom left shows the rise and fall in the from the Don River through to the Volga River, and you've got very high drops there, 30, 40 meters in places. And then a view on the bottom right shows the frozen canals, which obviously pose challenges for delivery. For subsea controls, so there's a subsea production system consisting of various items. You've got structures, workover control systems, umbilicals and processing. Subsea production systems are there to control the flow of hydrocarbons through a tree into manifolds and through to topsides. Very important, and obviously with the outcome from the Macondo incident back in 2010, BP took several safety measures to make sure that something like that never happened again. Got high pressure through the control system up to 15,000 PSI. There's an extensive qualification period through the engineering departments, and multiple clients are used. So for the controls, you've got FMC, ACA, OneSubsea and GE with highly specialized equipment. So this just gives you an idea of the equipment that is manufactured and fabricated and shipped out to Azerbaijan. So on the bottom left, you've got lengthy umbilicals that are manufactured in Norway. It contains all the communication cables and go through multiple strands. Top left, you've got a manifold. It's approximately 10 by 9 meters and controls the flow from the trees, which is in the bottom right. And the top right shows you suction piles. These are lowered onto the seabed. A valve's opened at the top, and then the pressure then is sucked down into the seabed where this frame eventually sits. This gives you a brief overview of the seabed with the manifolds here. The trees spread over where the wells are drilled down into the gas field below. You can see it's a fairly uneven surface at the bottom of the Caspian. Here shows you some lifts of the topside structures prior to they are floated out onto the jackets. Okay, so that gives you a very brief overview of the project. So in terms of the schedule aspect of the project, we had a lengthy review process, but Acumen Fuse was critical to us hitting our time. So we had a baseline verification check and also a monthly forensic check. So Acumen does both. With the baseline schedule, we're able to do a go, no-go check on the baseline schedule and ultimately see, is it worth looking at? We had tailored metrics aligned with the schedule requirements, so checking on float, checking on logic, checking on variances, and we were enabled to get a rapid response to suppliers. So if I had an XER sent through, within half an hour, I was able to make an assessment whether that was good to go or not. And basically,
people don't know XERs are a file, by the way.
Yeah, absolutely.
probably only a quarter of the audience know what an XER is, mate.
Yeah, sorry, a raw data file from Primavera from the scheduling software. It contains all the data associated with that program. It can be tens of megabytes in size. So it's quite a lengthy time to do it without Acumen. SD2 was time critical. So we took the baseline schedule from the supplier, loaded it into Acumen, and then took the month-end submittal and added as a snapshot. So this is the brief process for running through the schedule submittal, which is probably common across most industries. So you get the submission of the level 3. As a client, we reviewed the schedule, provided comments to the contractor. They would include comments, and then we'd update level 2. So prior to using Fuse, this time would take 3 or 4 days. After it, we were able to cut that time down and update the level 2 and save ourselves time each month. So that was a direct time saving. Cumulative each year, you'd save up to about a month a year. We've got some visuals from the Fuse here. So here's where you've got a file with 3,500 activities, and you're able to compare the baseline against the current plan and do a very quick snapshot on whether start and finish date's the same, any remaining duration's the same. We'd have 5 main suppliers, totaling about 15,000 activities. So we reviewed at the full baseline. Any changes to the logic or duration were needed approval prior to being accepted, and no rebaseline without the approval of BP. So we had a schedule narrative to accompany the monthly schedule that should explain any changes. However, when you load the file, you were able to very quickly see if any changes have been made. So this view, for example, shows by WBS any activities that have been removed from the program. So straight away, you had 5 removed. So you could see, okay, there's a variation order here. For connectors, for caps, and Yukon connectors needed for testing. We're able to pick up the phone, talk to the engineering department and say, was this valid? They could say yes or no, fine, tick the box, we could accept that. Similarly, you've got 140, 150 relationship changes here. You can see you've got many finish to starts now added in, and also changes to finish start to start relationships. So that tells me as a planner that they're trying to make the schedule more aggressive and overlap activities with extra resource. So if that was something that a discussion had been made in the month, we could verify that that was actually real or not, and then assign that off. We've got primary constraints, so 64. So as a planning person, you know that the constraints are a no-no. So you go through and see, is there any missing logic? Are there missing activities? You could go back to the contractor and ask them to rectify this to make sure you've got a free-flowing schedule going through. So to wrap up, you contact the supplier, verify the changes. If you agreed, you continue with the reporting. If not, please resubmit. I'd expect them to resubmit within 24 hours if they're on with if we are very clear with the actions to be input into the contractor schedule. Because at the moment, what I see on many schedules it's a lengthy process and actions are not picked up quick enough. With this, it's very straightforward and to the point. And we can see straight away, has that affected the critical path? The outcome is that the client had greater oversight of changes. So we could see, is it a schedule flaw or is it actually a verified change? So we could respond quickly, make timely decisions, and ultimately, first gas, which is when the hydrocarbons flowing out of the well, was achieved on the 2nd of July, which anyone with looking at risk was a P50 date. So that was seen as a success. And just to pick up on Val's comment earlier, risk is everyone's priority, so it does affect everyone. So having this process sort of links into that comment. Okay. That was a very brief run through of the Shah Deniz project, Phil. Thank you. If you want to contact me, there are my details, Twitter, on the website as well. Happy to hear from you or on LinkedIn. So thank you very much indeed.